Hello, and welcome to another RPD video. Today we'll be talking about stress breaking. Stress breaking is needed in situations like this, where pressure on the denture base area causes the rotation of the partial, and if the clasp does not accommodate stress breaking, it might transmit harmful forces to the tooth, eventually causing avulsion. So what is an appropriate clasp, and what is an inappropriate clasp? How does that problem occur? Let's take a look. Let's consider this mandibular class 1 RPD. The tissues in the back here are a little compressible, so when you add a partial denture in there and put some posterior pressure, you'll see that the partial denture might move like this. You'll also be able to see that this here is the fulcrum line connecting the distalmost rests, and this line here connects the two clasp tips. This tooth here is exhibiting excessive forces because the clasp is driving it upwards. That force might avulse it, and that is not acceptable. The reason this is happening is because the fulcrum line exists right in the middle between the edentulous space in the back that's being pushed downwards and the retentive clasps that are being pushed upwards. So how do we solve this problem? Stress breaking clasps. There are two options here. Either we change the rest-clasp relationship, or we just use flexible clasps. Let's start out with the same case we mentioned before, a class 1 RPD with a CC clasp on the distal abutments. In this case, the fulcrum line is right in the middle between the retentive clasp and the posterior segment. Let's shift that around and see what will happen. You can see here that we moved the fulcrum line more anteriorly and the retentive clasp tip more posteriorly. We did this by shifting over the CC clasp into an I-bar clasp that engages the mid-buccal undercut and shifting the distal rest to a mesial rest. Now we've created a situation where the clasp tip is on the same side as the edentulous segment. So when the denture base moves downwards, the clasp also moves downwards, disengaging the undercut and not transmitting any excessive forces to the abutment tooth. So that kind of solves it for the rest-clasp relationship shift. Now let's talk a little bit more about the flexible wrought wire clasp. Let's consider the same situation here, a class 1 RPD, but instead of a CC clasp, we'll be using a wrought wire clasp. In this case, we're not changing any of the clasp-rest relationship, just the material. Wrought wire is flexible. So despite the existence of the fulcrum line and the clasp tip in the same locations, the flexibility makes the forces dissipate, and the tooth therefore does not receive any excessive stress. So let's summarize. The problem happens because the fulcrum line exists between the clasp tip and the edentulous area. So when the denture base moves down, the clasp tip moves upwards, exerting forces onto the abutment tooth. To solve this, we could shift the relationship between the clasp and the fulcrum, like this. In this case, the clasp tip is on the same side as the edentulous segment. So when the denture base moves down, the clasp tip also moves down. Alternatively, you can keep the fulcrum where it is and just change the type of clasp. If you use a wrought wire clasp, the flexibility of the wrought wire clasp will absorb the forces and will not transmit it to the abutment. We hope that this makes stress breaking a little bit more understandable. Thank you for joining us for this video, and we'll see you again next time.